And the last example here in this video, find the equations of the tangents to y equals x squared from the external point 2, 3. Okay, so now we have an external point. This is not a point on the curve. Okay, so we're going to make up some point that is on the curve. Some point that is on the curve, and we'll call that x-coordinate A. So when x equals a, y from our equation equals a squared. That gives us a point of contact of a squared that actually is on the line and forms a straight line with 2, 3. Okay, so from this information, we have 2 points on a straight line. We can determine an equation for that. The easiest way at this point is if we already know the slope, and we can get the slope from the derivative, gradient, from the derivative function. So dy dx equals 2x. Okay, our point of contact is here again, so substitute a in, so 2a. So gradient is 2a. So in this case, we have a slope, gradient. We have 2 points. Let's choose one of those points to plug into our equation. Slope is 2a. Plug in, what happens if we plug in a squared, 2a, a plus b, a squared equals 2a squared plus b. So b equals minus a squared, which means the equation is y equals 2ax subtract a squared. Okay, just for fun, what would have happened if we plugged the other points in? 2, 3. Y equals 2ax plus b. 3 equals 2a, 2 plus b. 3 equals 4a plus b. b equals 3 minus 4a. So y equals 2ax plus 3 minus 4a. So these two equations obviously have to be equal to each other, which also means that 3 minus 4a must equal negative a squared, and we could solve for a. A subtract 3, this factors into a subtract 1, so a equals 1 or 3. Another way of doing the exact same thing would have been, and this is the way they did it in the textbook, another method right here is to substitute in 2, 3 into this equation, and you'll be able to figure out what a is then as well. We have 2 possibilities for a here. We have when a equals 1. So what's the equation of the tangent line when that happens? When a equals 1, we need to find that point of contact by substituting in 1 into our original equation. Original equation, x squared. So 1 squared, so y is 1, so the point of contact is 1, 1. We could determine the equation of this line based on this point of contact, this point of contact, and determine the equation altogether, just from those 2 points. So slope is 3 minus 1 over 2 minus 1, which is 2 over 1, which is 2. same as what we originally had said over here. Y equals 2x plus b. Substitute in one of the points. I'll substitute in this one. B equals -1. So the equation is y equals 2x subtract 1. Okay, secondly, when a equals 3, the point of contact is y equals 3 squared, 9, so 3, 9. Slope then is 9 minus 3 over 3 minus 2, 6 over 1. Slope is 6. Substitute the point in. So the equation here, in this case, is y equals 6x subtract 9. Okay, so two tangents pass through the point 2, 3. Okay, so two solutions there. This equation and this equation. So just taking a look at what that graph would look like, those two tangent lines would look like. Here we have the graph in blue of y equals x squared. We have the tangent line 6x minus 9 here in red. We have the tangent line 2x minus 1 in black. And then I just found the point of intersection, and that point of intersection between those two straight lines is 2, 3. That was our external point of contact. And so you can see that this is possible to exist, that there are two tangent lines that both go through that external point. So just wanted to give you a frame of reference as to what that looks like.